All right, nice to meet you. My name is Arthur, and in today's class, I wanna show you and guide you through the JWT. So, what is JWT? Where can we use it? How can we implement one? So, all those things we're gonna cover on this tutorial, and we're just gonna get some context, some basics, ideas, some core ideas, and after that, we're gonna move into the code and actually build something that we can actually understand how the JWT works behind the scenes. So first of all, let's just understand about what is JWT. So JWT stands for JSON Web Token. And what is that exactly? So basically, they are self-sufficient, and we're just gonna cover that in a minute. Tokens used to securely exchange information, of course, in the JSON format. So basically, JWT, it is used within the web to exchange information from the front end to the back end and vice versa. And we're gonna exchange that information using the JSON format. So let's just understand now about this self-sufficient word. So self-sufficient and self-contained, they're pretty much kind of related, especially in this scenario, because tokens carry within themselves all the information needed to be validated. In other words, they are self-sufficient. So what does that even mean? So when you have JWT, all the information that we actually need to validate and check if that user is valid or not, it is within that JSON. So we don't need to fetch or get any sort of information. We can only do that using the JWT that we have. Next, we know that the JWT is stateless. So what does that even mean again? So because they are self-sufficient, we don't need to store anything on the server. So whether this is a cache or the database, we don't need to save nothing. So that's why they are stateless. If we need to save something on the backend, that will make them stateful, which is not the case. So since all the information it is within the JWT, there is no need for us to save that information on a database, for example. And lastly, it is multi-language. So again, because we are using the JSON format, basically any programming language or decent programming language can read and manipulate them and check if they are valid or not. So that's pretty useful, especially if you have a microservice and you have different types of programming languages like Python, Ruby, Node. If you send that token to one of those servers, they can actually independently check if that JSON is valid or not. Great. We kind of cover a few of the main concepts. Now let's just understand some examples. So in this small diagram here, we have a traditional session-based authentication. So a front end, a client makes a request. In here, we have this elastic load balancer, which can be a little bit more advanced, but just keep in mind that this is gonna handle the traffic to one server or another one depending on their needs. So, but let's suppose for this example, let's just understand the main concept, which is the client makes a request, the load balancer points us to the server number one, which is the one available. We save that information and store that in that server. What happens if out of the sudden the server one goes down, or for some other reason the load balancer points us to the server two? We don't have that session, that authentication is stored in the server two. So that is gonna fail. So that is gonna just send us a request fails, the session was not found. Of course, we can bypass this by using a cache or another database, but that just adds more complexity. And that's where JWT enters. JWT, when you are on the front end and the client makes a request, every time we send the JWT on every request. Mainly on the authorization header. So when we do that, it doesn't matter if we are pointing to the server number two or to the server number one. Those servers, they can check and validate if that is a valid token or a not valid token. So they don't need to communicate between them. They can just check within their own, and that's good. So that's why they're stateless. That's why they're self-contained. All the information that we need, it is inside the JWT. Okay, now maybe that was too much. Let's just actually see what a JWT looks like. So in this image, this is small text, we can see that this is actually the JWT. So in here, we cannot understand any of this, of course, but inside here, we have all the information that we need to check if that user is valid to perform some sort of operation in our application or not. And we can see that it is divided between a dot. So we have one dot here and we have another one down here. So that basically tells us where one part of the JWT starts and when another one starts. So let's just break it down and understand one by one. So here on the first part, we can see that we have the header. So basically the header has the type and the algorithm in which we are going to use. Just hold for a second because we're going to see that in a minute. So the algorithm for this case, it is the HS256. We're going to see that in one moment. And we have the type, which is basically JWT. This is just a convention, you know, using the type JWT. But we usually use it since it's a common way to create that type of token. So the header is pretty much this. It's simple. No worries regarding this one. We are usually not going to be changing this too much or even caring about this one too much. The second one, this one is more important because this is where we actually handle saves, checks, and see the information. So the second one is the payload. The payload is the place in which we save information, or the place in which we actually can get some informations from. So for example, in here, we can save the issued ad. So it's the IAT. It could be, it's just like the created ad, but in timestamp. So just for us to check if that is a valid token or not. We're going to see that in the code. We can pass if that's an admin or not. We can pass the name, and we should also always pass the sub, which is the subject. It's just a way to identify that these tokens belongs to someone. It could be some sort of client ID or some sort of information. The important part about the payload, we can't never save important information inside here. So never store your user password, never store those type of sensitive information, because that information will be on the front end and will be being exchanged across your backend and the front end. And most importantly, all that we see in here can easily be decoded. So that's something that we should cover now, in which that information is just a base 64 URL encoded. So this is just a string. We take that string, that JSON type of string, and we encode that to a base 64 URL. That's just basically this. So anyone can just copy this, copy and paste into another decoded app. We're gonna see that in a second, and see whatever we are sending inside here. So this is not for sensitive information, okay? This is just for us to send the admin, for us to check information, for us to handle that on the backend, but that is not a place for us to save sensitive information. Just keep that in mind, okay? And lastly, we have the third part, which is the signature, which is definitely the most important place inside the JWT. So this is where the algorithm enters our play in here. So basically, the signature, it is a hash. We're gonna see that in a minute. So what we're gonna do, we are gonna basically, I'll just remove this. So this is just an example. So what we're doing inside here is that we are taking the header, the payload, we are splitting that into three parts. So we have the header, the payload, and the signature. This is important to understand. We're gonna concatenate both the header and the payload, and we're gonna pass the secret for the hash. And in order to create that hash, we are gonna use that algorithm. This algorithm cannot obviously be changeable. We don't need to always keep this format, but it's just for an example. So this will create for us the signature. So that's basically what we have in here. Now let's just dive and understand First of all, about the hash mechanism in here. So this is a poor type of company, a poor type of company. So that means basically that if, for example, here we have another this type of function, which you receive an A and a B as parameter, and you just return the A plus B, which is just we're just summing things. So let's suppose I call the function sum, passing the values 2 and 2 for A, and then B is equal to 2 as well. What happens if I call the sum function over and over and over again? It will always return 4 because 2 plus 2 is 4. So this is a poor type of function. So it is just a function that will always return the same type or the same output when we pass the same input. So that's kind of obvious and basics, but that's just what it is happening inside here. If I pass the base64 header and I pass the base64 encoded payload and the same secret, that will always create the same signature. And that's actually what we want. We want to be able to always create the same signature so that we can compare. Okay, so that was a lot. Let's then just understand how do we actually validate if that token is valid or not. So basically, we're gonna compare what they sent to us with what we have already. So let's suppose this other diagram. We're just gonna illustrate a little bit more into more details. So we have one mobile phone here, which is just a client, which is just someone making a request through their phone. We're gonna call the auth endpoint, passing our email and password. And that will validate to check if we exist or not, if that's correct or not. And that's gonna create for us the token, generate the secret and compare with the JWT. So now the next time we call our server, we're gonna pass that same JWT. That can be saved on our cookies, local storage, doesn't matter. And then we're gonna send it to a protected route inside the server. So that's basically how we structure. The user makes a request with their login, we're gonna return a JWT and to say that it's valid. It can perform operations inside our server, inside our application. But what happens if someone changes that information? What happens if someone just changes to, instead of is admin true to false, or change their name or change their subject? What happens in that case? Well, this is where the signature enters. So in here, on my left-hand side, I have the JSON Web Token page. This is super useful when you're first starting to understand about it. So in here, we just see what we covered. We have the secret, we have the payload, and we have the header. It's important to mention that the secret, we will never have access to it on the front end. The secret should be super protected because it is the secret which is gonna determine if that is a valid token or not. So basically, the secret is gonna tell for us that if that token is valid. So basically, this is definitely gonna be saved inside an environment variables somewhere super protected, okay? Never on your front end, never expose it to anyone. And that could be mainly anything. It could be only like secret. It doesn't need to be anything complicated, okay? So just gonna generate an example. I'm gonna select the algorithm that we'll be using. I'm gonna generate an example. So here we have signature. Okay, so now we have a valid JWT. So what happens if someone changes that information in here? So if someone out of the sudden changed the information to, instead of John Doe to, I don't know, John example, the payload will be different, right? Once the user sends that and sends that to our application, so the header will be the same, but the payload will be different. Why is that? Because we changed it from John Doe to John example. Okay, but the signature keeps the same. When we first send this to the server, what we're gonna do? we're gonna split the header, the payload that we got from the client, and the signature. And then what we're gonna do, we're gonna take that header, which the user hasn't changed it. We're gonna take the payload in which the user changed it to John example, as we saw, and we have the secret on the backend. So that is gonna create for us the signature. And what we do with that, we basically just compare this signature with the signature that the user has passed to us. And that's how we determine if that token is valid or not. Because this one will not be changed. This one will not be changed. Only the payload will be changed. And if the user tries to change the secret, the signature, then of course that will also breaks. So that's the main idea. If the user tries to change any information inside the payloads, we are always gonna check based on the secret in our backend if that signature is the same as the signature that the user passed to us. So it's a super simple but also effective way to say if someone has changed or not their payload information. So that's basically it. Maybe that was too much information, but I just wanna for you to understand that basically the most important idea inside the JWT is that we have three different parts. So we have the header, the payload, and the signature. The signature is the most important one. The secrets will always be stored in a super important and also protected place inside our application, so it's never exposed. Because if someone has access to our secret key, then they can also change and do anything, and that will be a valid token. So it's super important for us to keep the secret safe, and that's basically it. So if the user tries to change or do some sort of things inside the JWT, we can always validate if that JWT is valid or not. And as I mentioned, if we are handling inside a protected route, we will always be sending the JWT token to our server so that our server can check if that token is valid or not. Okay, that was a lot of information. We're just gonna dive into the code right now and understand how does that actually work. We're not gonna use any type of library. We're gonna build from scratch, and just for us to get an idea how that validation work, how that signing part work, in which we create and check if that's valid or not. Okay, let's dive into right now. Right now that we saw and understand a lot about the JWT in concepts, in theory, let's just implement one from scratch. And for that, just open your VS Code or any editor that you like. And I have already created a folder. You can also do the same. Just go into your computer, create a new folder, open that using your editor. And I will be using Node with TypeScript for this project. So just gonna go with a npm init. That's just create for us our initial package.json boilerplate. Okay. For that, I'm gonna also be installing TypeScript. So we'll be using TypeScript for this entire project. I'll be also installing the type nodes as well for helping us. I'm gonna also be installing the TSX as well. So this can actually help us while coding. So our application can just refetch for any changes that happens, okay? And inside here, I'm not gonna be using this tests. I'm just gonna be updating to do our TSX watch in this path. We're just gonna create this, and we're gonna call the npm dev to execute this inside the index.ts. Okay, let's just go again and click on index.tx. We're gonna go and do a console.log. Just click in here, and we're going to just do a hello TypeScript for now. Hello TypeScript. Okay, here we go. And now just type npm dev, and that's in watch mode. So every time I change anything and click saves, I'm just gonna update for us. So that is great. Okay, Now, we will be developing this application based on another library. And I'm not saying to you that every time that you create your application, you should do what we're gonna do now. No, this is just for us to understand, like, how can we validate? How can we create our own JWT? So I'm just gonna go back here to my browser. And in here, I have already clicked in this npm package, which is the JSON Web Token package. Probably the most famous one, it is this one. So this is just a library, a package that we can install inside our application and use it to validate, to create tokens, to check if they're valid, and many other things. So we can go to their homepage as well and check for some informations, which is pretty much the same that we have in the npm. But here we can see how to install it, how to use it, and we will be using the same type of word naming, like how we name the functions. So we have the sign, and we also have and yeah, we can pass any information here. We should pass the secret always to the sign word, to the sign function. And in here we also have the verify, which is actually going to verify if that token is valid or not. And you can see that it's pretty basic, it's pretty simple to use. So every time you create a new application and you will be using the JWT for handling that type of validation, my suggestion is that just go with this package. It's super simple, super easy to install. Just go ahead, install it, and you're good to go. But for this tutorial, my goal it is to explain to you how that works behind the scenes. That's good for training logic, but that's also good for understanding with more details, going to more depth in which how the JWT actually works. So that's just a heads up, just for you to know that you don't actually need to be building this entire thing that we'll be building now, but it's important for us to understand how that actually works, okay? So right now, let's just create that sign.ts function, okay? So we're just gonna export that function. And as I mentioned, we will be using TypeScript. So everything in here will be typed. So I'm just gonna create a new interface. And basically just gonna pass it in here. So inside here, we have to create three main things as we spoke. So we have the header, we have the payloads, and lastly, the signature, okay? The header we can create inside here. So we're just gonna do a const header. And as we spoke, we have both the algorithm type, in our case, will be just the HS 256, but that can also be changeable. We can pass this as a parameter. We saw that on the library, this can also be changeable for anything that we want. And the type will be just JWT, okay? Which is pretty much the same thing that we saw both on this page and actually on this one as well. So we have the type, which is JWT, and the algorithm. It's important to mention that you can see that all the words are like shortened, you know? Why is that? Because if we save or we add too much information, that is not going to be performant, that's not going to be useful, especially in the front end. That's why it's super important for us to try to reduce as much content as possible. And that's one of the reasons why that is always shortened, because this is going to just be type, but we keep this as a convention, okay? The next thing that we are going to cover now is the payload. So basically, the payload is the issued at, so it's the date in which it was created. I'm just going to go with date.now for this, which is going to create the current dates in milliseconds. And inside here, as we saw, we will need to be passing any information that we need, any information that we want. So you can be passing the subscriber, the subject, sorry, the name, the admin, or any other information. So for that, inside here, I'll be creating the data, which is something that we'll be passing inside here. So the data is just an object. So we say it as a record, and it will have a string and any inside here. Why any? Because we can be passing anything. We can be passing an array, an object. So anything could be inside here. And I'm just gonna be destructuring this and passing inside here. Just gonna do one more thing. We're gonna go with just gonna create an editor config so it can help us with that Command and Control S. Okay, that's good. That's fine. Perfect. Now, this is also gonna we're also gonna need a few more informations in here. So the secret is something that we also be needing to be passed inside here. So the secret is something else that will definitely need to be passing, and also the EXP, which is the expired ad. So it's just like the time in milliseconds in which we want to expire the JWT, so that the user needs to be going through the signing process again, and that's just going to be a number. Okay. All right, I think that's good for now. Let's just take this out for now. Just take the data, the secrets, and the expired, and let's put it all inside the payload. Okay, gonna also pass the expired ad and the secrets. Perfect. Just gonna do a console.log inside this so that we can actually see that happening. So passing the payload. Perfect. Right. Let's just now instead of putting that inside the SRC, I'm gonna create a new folder, call it a JWT, like this. And inside here, I'll be putting our signing function, and later on another function. But for now, let's just call this so we can do the signing. And in here, I'll be passing the data, which is basically an object. And here we can pass any information that we want. I'll be just copying and pasting this just so that we can have an idea about how does that actually look like. And okay, like this. We are also missing the secrets. The secret will just be secret for now, which is just a string. And we also have the expired at, which is just a date in milliseconds, just gonna go with 1. And with all that said, if we open here, we can see our payload, okay? Now, once we go in here, we can actually dive into more details and see that we have the subscriber, the name, the admin, the expiry date, and the secret. So that's basically all we need for us to create now the signature for this one. So let's just try something different now. Instead of this, I'm gonna go with my name, session. I'm gonna remove this and this, and I'm gonna create a key, just creating an admin, just gonna be an array for us to demonstrate this. Let's just go with valid, just so that we can see that it could be an array, it could be any type of information. All right, now let's just move into the next part. Now to the next part, we need to, first of all, just change the expire date, which is just a number. So in here, what we can actually do is, let's just go back here to the index, and instead of just the number 1, we're gonna do a date.now, which is just gonna take our date that we are right now. And I wanna expire this token into like for the next day. So the user can be authenticated for an entire whole day. And for that, we can do just a simple multiplication. So a day has 24 hours. We're gonna multiply that by 60 which means 60 in 1 hour we have 60 minutes, and then we're gonna do that again for now get the seconds, and then for the milliseconds we're gonna do that times 1000. So by doing this we actually can expire a user just after 1 day. All right, I'm just gonna remove this admin just to keep things simple. I'm just gonna keep here a secret, but this could just be any information. It's just important to mention that this would actually be on your environment variables, okay? Not in here. All right, now let's just understand how can we create our signature. You remember that we first saw it here on the diagram, in which we actually need both the base64 encoded header and the base64 encoded payload. And that's pretty simple when we are using Node.js. So let's just go inside here, inside our VS Code project, and let's inside here go and create our encoded base64 header. So just gonna use the same type of written in here. So it's a base64 encoded header, and for that we'll be using the buffer. So if we do a buffer dot from and we just copy and paste here our header, that should be a string. So and do it like this. Let's just do a console.log and see what is happening inside here. If I do a console.log and actually paste this and show in here, we can see that we have some sort of digital numerical ways of seeing things. So this is just how we're gonna convert this. So now that we have this first buffer, and here since we are using a JSON, we actually need to do a JSON.stringify header. And now we can see that we have even more numerical values. So this bunch of numerical values represents that JSON that we have here on the header. Okay, now for the next part, all we gotta do right now is do a toString method, and that's just gonna get us back. But in order to convert that to the base64 URL, we can easily do like this, base 64 URL, and this is just gonna convert this into that encoded base64 header that we spoke before. Just gonna break this down just so it's easier for us to understand, and we're gonna do pretty much the same thing, but now for the payload. So the payload will have the exact same type of format, which is just like this. But instead of header, is gonna be here payload, coded payload, buffer toString, and we're gonna be using the payload inside here. So if I do a console.log for those two values, we can see that it's pretty much the same. Of course, the payload will have more information because we are actually handling more data. We have the secret, the data, and many other informations inside here. So how we can actually now create that signature? Remember, the signature needs the hash. So as we spoke, the hash method will take both of this, the encoded header and the encoder payload together with the secret in order to create the header, in order to create the signature, sorry. So let's just create the signature. And for that, it's pretty simple. Since we are using Node, we can mainly just import from the Node crypto the create. So we can do just import create HMAC, and we can do that from the Node crypto package. And by doing that, all that we need to do is initiate that. So we can do an HMAC. We're gonna do a create Mac. We're gonna use this type of algorithm for creating our HMAC, and we're gonna pass the secret, and we're gonna just remove the secret from here. Okay, and by doing that, all that we need to do right now is actually going inside and updating this HMAC. So all we need to do right now is do, we can go here and click on signature, and that will be hmac.updates, and we will be sending both in a concatenated way. So here we can just do like this, and we'll be passing the encoded header dot the base encoded payload, just like this. And we're just gonna click now and digest that so that it has the base 64 URL format. All right. So by doing this, we can actually do a console.log and see what's that returning for us. So let's do a console.log and passing the signature, and here we have the signature. So right now, what we need to return, we mainly just need to return our header, our payload, and our signature. So that's just how the JWT actually works. So let's just return everything inside here. We're gonna do the same process. So just go inside. We're gonna pass the base encoded header dot the base encoded payloads that we have in here, and we also gonna pass the signature at the end. This is gonna use in order to validate the whole thing. Okay, so this is the signature, and that's all we need to check if that user is valid or not inside our application. Okay, now let's just move inside here and see what is this actually returning. Just gonna go here, just gonna remove this console.log so we don't get lost. Okay, and here, just gonna do a console.log inside that token. So let's see. You can see that we have pretty much the exact same token as we saw previous on our demo. So it seems it's important to mention that this would actually be changing every time I hit save. Then you can actually see that it ends with 5FQ. And right now, let me check. Okay, yeah, it is happening. It just was the same for one moment. So basically, we can see that every time that I hit that I click on Command S or Ctrl S, we are getting different informations inside the payload. And why is that? Mainly because every time I hit save, we are actually getting the date.now. And as the time passes, of course, this will be changing. But if I just come in here and copy this, I'll be going inside and just decode this code. We are going to actually be seeing exactly what we have inside there. So we have the algorithm, the type, the subscriber, and any other information that we are passing. So that's really interesting to say that how easy we can actually just copy and paste, and we can actually see inside. We have all in here, and we have the JWT, we have my name and anything. And it's pretty much this. This is actually how we create a token using the JWT style. And by returning or having the signature, we can actually validate and check if that token is valid or not. So right now, what we'll be doing is exactly that. You're gonna be validating if we have a valid or a not valid token, okay? Just here, I'm just gonna change this to options, just so it's better to understand. And okay, let's move to the next part. Now, let's continue our work by implementing the verify part. Just a heads up, I forgot to change this to uppercase. It's just better to use uppercase, but again, it's just conventional name. And now what we're going to do is, first of all, I will be creating inside the JWT folder a new file, this time name it verify. So this one will actually verify if that token is valid or not. So it's pretty much the same thing. We're gonna export a function. It will be called verify. For this function, I will be also creating an interface. I will call it I verify options. as well. For this one, we will be receiving both the token that will come from the front end, which is just a string, and also the secrets that will be only again on the back end, and that we can create again that secret. All right. So what I'll be doing here is I will be extracting both the token and the secret from here. And what I will be doing now, remember that when we first spoke, that what we need is actually taking that token and splitting that based on the dot. So that's exactly what we are going to do right now. So basically, we'll have the header, but that's the header that the user sent to us. So that's the header sent, the payload sent, and also the signature that the user sent to us. And basically, we will be taking that from the token, and all we need to do is do a token dot split, and we'll be splitting that based on the dot. So let's just do a console.log and see what we have inside here. Console.log. Here we go. I'll be basically just here on inside, I'll be basically just calling the verify, and inside the verify, I'll be passing both the token, which is pretty much the same that we have in there, and the secrets. Okay. Token equals to token. Now, let me check if I. Okay. Okay. Yeah. Sure. It's from the wrong place. So it should be from .jwt, and the secrets I'll be just creating one outside the scope. It could be just secrets or really anything. And yeah, here we go. I can also remove those from here, and here we go. Perfect. So now that we are calling the verify, we can actually see what we have in here. So it's gonna do my pnpm dev, and here we go. We have the header sent, the payload sent, and the signature. Perfect. So what we need to do now is actually create the signature, and creating the signature is pretty much doing what we did down here. So I'm just gonna create a new function. I'll be creating this file named generates signature.ts as well, and it's gonna be pretty much the same thing. So it's gonna be export function generates secrets, and actually the generate secrets will need a few parameters as well. So I'll be creating the interface for this one. I generate secrets, generate secret, perfect. And for this one, we'll be sending the secret, which is a string. We'll be sending the header, which is also a string, and the payloads, which is also a string. Okay, and now I'll be also taking those arguments from the interface. So I'll be taking the secrets, the header, and the payload. Right, and basically what we need to do is exactly this. So I'll be removing this from here, and I will be pasting it down here. I'll be also taking this imports that we have, gonna go in here, pasting here as well, and yeah, basically we're gonna be now creating signature. Now instead of this entire thing, we're just gonna do the header and the payload, and here we go. And instead of returning the signature, we can just return this. And perfect. If you wanna, we can also put on the other line just so it's a better format, but honestly that's all we need. And now in the sign part, all we need to do is call this signature. So and create a call signature equals to the generate signature, sorry, signature, generate signature. Okay, so I'll be just calling this right now. We're just calling the generate signature, and for that we'll be passing simply the header, which is the base 64 header. We'll be sending the payloads, which is also basically just the payload that we need. So payload, yeah, no, it's better. Base 64 payload. We can also split this. It's better for us to save. Just do multiple splits, so it's easier to understand. And lastly, we can just pass the secret. And with this, we can create the signature. So it's just a better way for us to move code around. And by doing that, it's easier for us to now do the same on the verify flow. So in the verify flow, what we're going to do is pretty much the same. All we need to do is come and generate the secrets. So I'll be just copying this and pasting inside down here. I'll be calling the generate signature, but I will be changing the names to payload sent and header sent. And now we can actually compare. So if the signature that the user sent and the signature that we just generated are different, then we have a problem. The signature is wrong. So it's pretty much like this. If the signature is different than the signature that we sent, then this is just not valid. So we can just throw a new error saying, for example, you just say invalid JWT token, just like this. All right, so now what we need to do is actually test this and see if that is actually working or not. Another thing that we can actually do is, besides checking that, we can actually check if the date has expired or not. And for do that, we need to actually convert that payload back again. So we're just gonna do const decoded payload. So we encoded that, so now we need to decode it. And basically what we need to do is use the buffer again, and using the buffer, we need to use the JSON.parse, and then inside here we will be using the buffer.from, and here this buffer.from will be using the payload sent, and we will be converting that to base 64 URL. So just like this, base 64 URL. Okay, now all we need to do is at the end of this, we just need to do a toString. And since we want this to be in a string format, we can just type OTF8, just like this. Okay. Just gonna split that a little bit just because it's easier to understand. Split that again, because it's easier for us to get the idea. All right, with that in mind, we can actually come here and do a check using the expiration date. So if decoded payload expire date is less than date not now, or in other words, the date has passed it already, we're gonna also throw a new error. And the error that we're gonna be doing now is just expired JWT token, and by the end we can just return the decoded payload. Okay, now let's just test to see if all of that is working or not. So here we have a token, and the same thing that we did there, I'm gonna also do something similar. So const verify equals to the verify token. I'm also gonna put this down below. And now we can actually see that we have the returned payload with the returned token, and basically what we need to do now is test and see if that is valid or not. So what I'm going to do right now is simply the simplest thing I can think about. I'm gonna use a different secret. So if I type like this, you can see that we get an error because it's an invalid JWT token. So basically, if the secret is different from the secret from the verify, it will fail since it is not valid anymore. It's just not the same secret. Okay. If I also try to, let's revert this. Now let's copy this entire token that we have. Let's go back to our JSON in here. You can see that we can just paste this. I'll be just copying this payload and changing it to be the data. So let's just mock and see if that works or not. So what I'll be doing right now is I'll be going to the index parts and I'll be sending this token. So instead of sending a token, I'll be sending my custom token. So it should be this one. Which is just a string, it's not an object. Okay. So by doing that, we can also see that we also got an invalid token, since this one is a totally different token that with a totally different key that we need. And you can also try to use the same key as the one that we sent. So for example, I'm just gonna replace from here. So this is the signature, and I'm just gonna use the current one. You can see that even though they're not gonna match, since it's just gonna generate something completely different from this using this new payload and header. Okay, so let's just remove this entire thing. And another thing that we can test is the verify part. So in the verify part, we have the decoded expired dates. So for us to check this, we can actually use a date in the past. So instead of doing a plus sign, I would do a minus sign, and you can actually see that we got an expired JWT token. Okay, so that was basically it. I know sometimes it seems to be a lot of content, but it's not really, you know. We kind of got the idea that we need to have the payloads, the header, we create a signature, which is really what's gonna tell us if that's a valid or a not valid signature. And we just return the JWT, which is basically this concatenated strings of header, payload, and signature. And basically on the verify side, we just check if that signature is the same signature as the one that we receive it. So it's pretty much this, and most of course, there are many improvements that we can do. For instance, we could pass for the generate signature which type of encryption that we want to use. Of course, we can change the algorithm to try to generate something different. As we can see here, there are different types of algorithms examples that you can try on and actually experience different results. But that's basically it. So that's JWT. On a nutshell, we covered many important details. We wrote our minor JWT sign and verify functions, which are basically a lot of encryption and decryption, encoding and decoding, and checking if that's valid or not. So I hope you like it, and if you have any questions or any suggestions for future videos, just let me know in the comments. And that's it. I hope you have a great day, and thank you very much.